Hi, in this video we're going to explore how to divide a surface using programming or using C# scripting. We've learned how to create a surface using RhinoCommon or creating an NURBS surface actually in the past two videos. So now we want to try to divide the surface. Actually, if we hit to the Rhino geometry namespace and we go to the NURBS surface or the surface class, in both we don't have any method that divides a surface to a number of points. So there are no division methods here. But still we can do it using iterations, using for loops, exactly nested for loops. And to do so, let's create a surface. So we've learned how to create a surface, a NURBS surface from points. Let's start creating this surface, surface A. That will be a NURBS surface dot create from points. And inside we'll pass the points, so we'll create an input called points, actually having a list of points. The U and V counts will be 2 and 2, and the degree will be 3. And let's create this surface and output it in the A output. Here in this case we need to add a points input that will have a list access and of a type point3D. And let's create our points. So we'll have a point component and set for points here. And once we connect it, this doesn't work because the surface does not exist in the current location. Yep, this should be surface A. Now if we run, we have this clean surface. Now what if we want to divide it to a number of points? If we have a surface here, all we have to do is that we want to get points, certain points at certain surface parameters, right? So in order to make this operation easy, we need to reparameterize the surface, meaning that we want the U and the V both to be equal to 1. So we need to set the domain of the surface in order to get a point at 0, 0 at 0, 1, a point at 0.25 and 0, and so on. So at first we will set the domain of the surface to be from 0 to 1. The first argument will be the U direction, and that will be 0, and its interval will be equal to a new interval from 0 to 1. And we're going to copy this line and paste it here, but this time we're changing the V direction. And now we're going to divide the surface using a U parameter and V parameter, meaning how much is the distance in parameters terms that we want to divide the surface with. So if this is 4, we'll call this the V param, and if this is 4 or 3 or 2, we'll call this the U param, and it's equal to 1 by the number of divisions. Okay, so let's now create two doubles, the U param. This will be equal to 1 by the U division, and another V param that will be equal to 1 divided by the V division. We'll create a list of points to save or store our points on surface or points at surface in it. So let's create a list of point 3D called divided points, and this will be equal to a new list of point 3D, and we'll leave this list empty. So now our first point will be at 0, 0. Our second point will be at 0, 0.25, or starting from here it will be 0, 0, 0.250, 0.50, 0.750, and 1, 0, and exactly the same. So we need here a for loop, actually a nested for loop, to create this grid of points, but instead of adding x, y, z locations to these points are points at certain parameters. So I want to create a point at 0.25 and 0.25. This point means the index that we're using in the for loop multiplied by the u parameter, right? Let's try this and get the sense of it. Okay, this is not like, this is called divided points. Now list of point 3D. That's it. Here let's start creating our for loop that starts with an integer I equals 0. I is less than the u division, and I increases by 1. So if my u division is 3, so I is less than 3, so it starts with 0, 1, and 2. And here in this for loop we need to create another nested for loop in order to deal with the j or the y or the v of the surface. So in j equals 0, j is less than the v division, and j plus plus. And inside this for loop we want to get the points. So point 3D point equals surface a dot point at the index multiplied by the u param and the j multiplied by the v param, and then we'll add this point to the divided points list. So add point. So now we can output our points, which is divided points here, and let's start creating our inputs. Our inputs, which are the u division, and that will have a type, a double type hint, and the v division that will have a double type as well. Now we have a problem that the name b does not, we need to add b. So now this code works well, and we didn't add any numbers to the u division and v division. So let's say that we're going to divide it from 1 to 20, and here the same. So 1 doesn't do anything. If we start here and start here, we actually have a problem. This is not dividing our surface, so it's not creating points on this line or this line. Let's check what the problem is. So most probably our problem is that because we didn't add a last point, because we said that I is less than u division and j is less than v division. But if we want to make this accurate, then the v division equals 4, so we need to make this less than or equal to, and this will work as intended. And here we can change this to divide the surface to as many segments as we want on both sides. So this is the way to divide the surface. As we've seen, it's not in the it's not a method in the surface class or the NURBS surface class. sometimes a lot of methods, let's say, need to be coded by thinking of the coding logic and not by searching for a certain method. What if we want to start moving these points in the z direction? A list of points cannot be moved as a whole list. So in the list class or list collections, with the RhinoCommon collections, we cannot try to move divided points by saying dot translate or so, but we can move each point alone using a for each loop. So if we want to move these points, let's create a list of moved points, and that will be a list of 3D called moved points, and let's keep this list empty. So in order to move each point alone, we can use a for each loop, and for each point 3D pt in the divided points list, we need to do the following. We need to transform pt. We need to move this every point alone, so pt dot transform, and in order to make a transformation we have to type transform here again. We'll review this special code in the transform namespace in Rhino later in other videos, but right now let's just write dot translation and let's translate it using a new vector 3D that goes 0 0, and let's call anything, let's say 10 units, and we have to close this one and this one. So now we need to add this point to the moved points list by typing moved points dot add pt. Now we have a list of moved points. If we want to show them, let's add them here. So c equals moved points, and if we run this and add the c, we'll have our points moved. No, they're not showing. Why is that? Oh, there are some points in the c, but yeah, here the 10. Okay, we want to view them better here. Okay, again, what if I want to connect every point with another, with the upper point on the upper coordinate exactly? So in this case we need a for point in order to connect the points of the lower level with the point of the upper level, which has the same exact index. So I need an index in order to connect those two lists, and so I'm going to use a for loop. So I can at first add create a list of lines in order to store my lines in it, and let's call it lines, and that will be equal to a new list of line. And let's initiate a for loop where integer I equals 0, I is less than the whole number or count of one of the two lists, so anything will work. I is less than divided points dot count and I plus plus. In this for loop I want to create a line called line that will be equal to a new line connecting the point of divided points that has the index I with the point in the moved points list that has the index I. And now we'll add the line to our list. So that's it. And in order to show these lines, we'll have to say d equals lines. And let's add a d here and run our script, and we have a grid of lines connecting each point and the other. In order to have a better sense of this, let's say that we want to connect this point with the point with the next point in the upper curve, or in the upper list of points. We have just to add 1 to the index of the moved points, and then this point will connect with the point with I plus 1, and this one will connect with I plus 1, and so on. But we have a problem here. If we run this code, it will not work, because you will have an error called index was out of range. Why is index out of range? Because when we reach to the last point here that has an index, say, of 12, which is the most number of points in the list, it will try to connect to the point at index 13 in the upper list, and there is no point at index 13 in that list. So we need to call this the last one. So mainly we can just say that I is less than divided points to count minus 1, and this will exclude the point with the index with the last index plus 1 in the upper grid of points. And that's it. Thank you for watching this video. If you have any comments, please type them in the comments, and if you like the videos and the contents, please like the video and share our channel and subscribe to it. Thank you, and see you in another video.